Here we're going to solve four equations that are said to be quadratic in form. And before we do that, I'd like to say a few things about quadratic functions in general. Our standard quadratic function f of x is in the form ax squared plus bx plus c. If it is applied to another function, let's say h of x will be substituted for x everywhere that it occurs. Since h of x is a little cumbersome, let's substitute w for it. So w is a function of x. In the first case, when we go to look for w, notice that bw is generally our middle term, as long as the powers of the terms are decreasing. So in this case, a logical choice for w would be x cubed. So w is a function of x, actually. W is x cubed. When I substitute, then, instead of x to the sixth, I have x cubed squared, so I have w squared minus 342 w minus 343 equals 0. The numbers are large, but this expression is easy to factor. It's w minus 343 times w plus 1 equals 0, which gives us w equals 343 using the using the principle of square roots, or w equals negative 1. But we're not solving the equation for w, we're solving it for x. Originally, we took the x cubes out and put in w. Now we're going to take the w out and back substitute the x cubed. So x cubed equals 343, or x cubed equals negative 1. We take the cube root of both sides of each of the equations. Cube roots are the inverse of cubes, so we get x equals 7, or x equals negative 1. There are two solutions, x equals 7 and x equals negative 1. Now we have three other examples that will work in a very similar way. Here we're going to let w equal x to the fifth, x plus 7, another function of x. Notice that x plus 7 appears in the middle term, but x plus 7 squared occurred in the first term. So when I substitute w for x plus 7, I get w squared minus 5w minus 14 equals 0. this factors as w minus 7 times w plus 2. Thus w equals 7 or w equals negative 2. So first of all, we put the w in for x plus 7. Now we're taking the w out and replacing it by x plus 7. So x plus 7 equals 7, or x plus 7 equals negative 2. Subtract 7 from both sides of each of these equations gives us x equals 0, or x equals negative 9. The two solutions are 0 and negative 9. So let's move to the third equation. The third equation is x to the 8th plus 35x to the 4th equals 36. Here we have a preliminary step. We need to subtract 36 from both sides of the equation to get the equation equal to 0. Now, x fourth squared is equal to x to the 8th. We're going to let w equal x to the 4th. So when we substitute this, we will have w squared plus 35 w minus 36 equals 0, which factors into w plus 36 times w minus 1 equals 0. So w equals negative 36, or w equals 1. Now we're going to back substitute. We're going to replace the w by x to the 4th. And this time we remember that there are no fourth powers of real numbers that give a negative. And in these problems we were looking for only the real solutions. And so in this case we'll say that x to the 4th will not be able to equal negative 36, so there's no solution for that part of the equation. But x to the 4th can equal 1, and as a matter of fact, when we use the square root principle, we would get that x squared equals plus or minus 1, since x to the 4th was x squared squared. Now x squared cannot equal negative 1, at least there's no real numbers for which x squared can equal negative 1. But we're told x squared can also equal 1. So no solutions here. But now we see that using the square root principle, that x equals plus or minus 1. Two different solutions, positive 1 and negative 1. Our last example may look a little bit unusual, but notice that when you square the square root, you do in fact get x itself. So the form of this equation can be clarified by letting w equal the square root of x. Then what we will have is w squared minus 9w plus 20 equals 0. This is w minus 5 times w minus 4 equals 0. Thus w equals 5, or w equals 4. But when we back substitute, we get that the square root of x equals 5, or the square root of x equals 4. We can square both sides of each of these equations to get that x equals 25, or x equals 16. So there are two solutions to this problem. Notice you can always check by substituting x equals 25. The left-hand side of the equation would get to be 25 minus 9 times the square root of 25 plus 20. So it'd be 25 minus 45 plus 20, which does in fact give us 0. If x equals 16, we'd have 16 minus 9 times the square root of 16 plus 20. That would be 16 minus 9 times 4 is 36 plus 20, which is in fact 0.